Alright, I'm back. The internet just got disconnected for whatever reason. So we have a new idea. Okay, we have a new idea. So this new idea is, we'll sort the ranges. Okay, we sort the ranges. Then start from the first one, right? We get whatever range, and then we record the right max. Okay, that's the first one. Doesn't matter what it is. We record the right max, and we'll always cover the 0, so no problem. So we have the right max. And the next one, right? The next range, if its left is smaller or equal to this right max, and the right is larger than, then this is the next right max. We record the next right max, and yeah, we record the next right max, right? And this one will add a new, and if this one is smaller than, then we just ignore, right? If it's larger, if this is smaller than the current right max, this is larger than this, then we will add 1, right? We add 1. So this one first plus add 1, this will add 1, and then we have a new one, right? As long as it's smaller than the previous right max, then we will make this as big as we can. So we keep doing until we have something, right? We have something that's, even if it's equal to, it's fine. We just keep doing when it's larger than the previous right max, right? Larger than the previous right max, then we'll compare to also the current right max, right? If it's larger than the previous right max, and or compare to the current right max. If it's smaller than the current right max, then that's the original situation, right? We don't really change anything. But if it's larger than, yeah, whenever we find something that gets out, then this will become the current right max, right? This will become the current right max. And then this, if it's not, then we just don't. If it's become bigger, then we also plus 1. So one of the edge cases is we have the current right max, right? And everything, if it's smaller, and then suddenly, boom, I have something that's larger than. So when it's larger, then we need to find if we have a next right max. Now, if the next right max is larger than this, that means, yeah, we have found something. Actually, no. When it's larger than, we do this check, right? Because it could be we don't have the next right max. If we don't have the right next max, it's already not possible. As we have the next right max, then we need to continue, right? We need to continue do the current one to check. So it will be a little bit more involved. So let's just give it a shot. I think as we code, I'll be able to have a little bit better idea how it should be. So first things first, we need to sort this thing. Right. So how do we sort? I don't know. I do this. Wait, hold on, no. I do this. It doesn't select the ones I want to select. That's not what I want. Yeah. I have to do it twice. Anyway, I have ranges, right? Can we say arrays dot sort ranges? I can do comparator dot compare int tuple 0. So we sort. Oh, sorry. Dart. That's not ranges. This intervals. Okay, intervals equal to new int. That's gonna be 2. This would be ranges dot length. Okay, then for int I equal to 0, I smaller than, and oh, it's gonna be n. My bad. This is basically n. Right, and then I plus plus. What we say is intervals I 0 equal to I minus ranges I or can we say this equal to this I minus ranges I plus ranges I. Can we do that? No. How about new int? This is allowed. This is allowed. But I'm not sure if you want to do it this way though. Yeah, I don't think that's my style. I'll just do it this side. And I'll do intervals I1 equal to this. Yeah, I think I'll do this. Okay, so I initiate it. Now for this, what I'm going to do is do intervals. Then this is a sort by left. Okay. Now what? Now we can say int right max shall equal to let's say math dot min, no, integers main value. So it's the right max, the previous right max, right? And then we can say the next is also equal to integer dot main value. So we have the start, and we say int I equal to 0 while I smaller than n. So we have to go through every single one. All right, here's what we do. For each new intervals, we need to check, right? We need to check. Actually, no. This shall equal to intervals 0, 1. I shall equal to 1. Okay, so now for each one we can say if intervals, we probably also need int res equal to 0, now equal to 1, because I already turned on the current one. So if intervals I 0 is larger than right max, okay, if it's larger than right max, now we have two more situations, right? Two more situations. The situations if it's smaller than the next right max, or it's bigger than a right max. And what I say is if it's bigger than a right max, then we can just say if intervals I 0 is larger than next right max. That's the case. All right, if that is the case, so it's larger than the right max, so it's larger than the next right max. If that is the case, then we have there is a gap not fillable. So we just return a -1. Right? Else, if it's smaller or equal to the next right max, right? If it's smaller or equal to, so the current one is larger than the previous, but it's smaller or equal to the next, so we can continue, we can keep going. So now we need to do right? If it's smaller than, what we need to do is to set right max equal to next this, right? This is basically the current right max, and next this one shall equal to integer dot min value. Then we'll continue, which is fine. We just continue. We don't change I. We'll hit this I again, right? And when we hit the I again, we will basically call this else, right? Else, the left is smaller or equal to the right max, okay? If it's smaller or equal to the right max, now what we want to do is to check if intervals I1, if that, okay, if that is larger than next this, the right, the current interval to the right, if this is larger than the next right max, right, then we actually we don't do anything. It depends, right? Depends. So now we set up something and we just need to keep going. Actually, no. I think what we need to do is to check if this is larger than, if it's larger than right m, right? If it's larger than right m, if it's not. If it's larger than right max, so the left is smaller or equal to right max, the right is, so that has a potential, right? We have a potential to increment the result, and we'll only increment the result if next this is equal to integer dot min value. If that's the case, then rest plus plus, right? So this basically we say we have found a new so this is new extension, a new extension to the right. So we which means we need to turn on a new tab. So we increment this, right? But if it's not, that's fine. And then at the end we'll say this shall equal to mass.max next this and intervals I and 1, right? We'll get the max between the two. What? Result of max is the same as the second argument. How? How is the same? You don't know that. All I say is this is larger than Rm, right? This is larger than Rm. I didn't say if this is larger or smaller to the next Rm. It could be smaller than next Rm. If it's smaller than next Rm, then we do this, right? If it's bigger than the next Rm, then we take this. So I don't know how they figure this one out, but it's fine. It's fine. We will handle this. Yeah, that's basically it. So the right, if it's larger than Rm, right? If the right is larger than Rm, then we will see if the next Rm, right? If it's actually Rm, we'll do this, and then the next Rm will equal to the maximum of this. Else. So else is the right is not larger than rm. So if the right is not larger than rm, we just don't do anything. We don't increment. We don't do anything to the next rm. We just keep everything the same, right? So this the else branch, it refers to intervals I1 smaller or equal to rm, in which case we don't do anything. Well, not necessarily, because you need to increment, right? You need to increment. So no matter what, once it is done, I need to plus plus. Right, no matter what, I need to plus plus. If this, like, we'll basically handle it, either it's inside or it goes outside, right? And then blah blah blah. Once the left become bigger than a current rm, which is basically this situation, then we have the next rm. So if it's smaller than the next rm, we'll return the rm to the next rm. Yeah, we swap that. Next rm basically become nothing, and then we run this over again. So we'll do that, and we'll return the rest at the end. Okay, time to give this a shot. Does it make any sense? Nope. Okay, we need to debug. That's fine. We have done this many times. Three, 4, 1, 1, 0, 0. What's this? Min tabs and ranges. Okay, let's put a stop here. Okay, let's debug this thing. All right, ranges. What about our intervals? I don't want interval I want the whole intervals. 3, 5, 1, 3, 2, 4, 4, 4. Oh, what happened? This happened. I forgot to do equal to. Okay, that's the first issue. Let's see, let's go to run. Out of range, of course, because this should be +1. Interval shall be +1. So I'll try it again. Okay, still 2, so we still have issues. That's fine, let's just debug. Now the intervals, okay, intervals correct. Right max is 3, okay. Okay, I equal to 1. Now let's F8. Goes in, I smaller equal to 5, which is correct. Interval, this is 5. It's larger than the 0, no, it's false. 1 is larger than, that is true, because Rm is 3. The current interval at this value is 5. So that's true. And next, that's true. So, oh. I forgot to check one thing. I think I forgot to check one thing. So we have the rightmost, right? In the current one, extend even more. Yeah. because the current one I have a 0 to this, right? So it extends more to the right, but its left is smaller than 0, which means we don't have to consider, right, the new one. So if it's smaller than 0, then we don't. Okay, so if this and maybe I need to change this. We say if this and intervals I 0 is larger than 0. It has to be larger than 0. If it's larger than 0, that means the previous one must be taken. But if it's smaller than 0, then we don't have to take it. So now it becomes 1. So we just add a 1 piece of code. Let's see, where is it? Here. Right. Let's just run it. If it's not right, we'll just try an error. Okay, it's not right. It's just fine. I expected it. Usually how things go with difficult problem. Just have to go through them many times. Alright, so we have 7. So 1 is -1 to 1, right? -1 to 1. Next one is -1 to 1. No, -1 to 3. Because it's 1 minus 2. 3 minus 1. 3 minus 1 is -2. 3 plus 1, 4. I'm going to cover 0 to 7. Right? Next one's 0. So that's 0, 1, 2, 3. So that's 3 to 3. 4. 4, 2 to 6. 5. 4 to 6. 6, 6 to 6. 7, 6 to 8. Okay. So I'll take -2 to 4. Right? And we have -4 to 6 and 6 to 8. 3. My output is 2. That's very interesting. Okay, deserve a inspection. Let's see what went wrong. Swap this 7. 1 2 1 0 2 1 0 1. Okay, debug. Alright, check intervals. Is that the same as the interval we have? 2. Oh, 0 1 2. This is not right. My bad. 2 minus 1, yeah. 2 this is -1 3. -1 3. But it doesn't really affect. So basically the first one will be -1 3. Right? And then we have 2 to 6. And then we have 6 to, yeah, so it doesn't really affect. It's okay. So we have -1 3. So the right should be 3. Then 2 to 6. Now we have 6. And then we should have 6 to 8. Okay, let's see what goes wrong. Okay, so I have -1 3. Right most is 1. That's the starting point. Because -1 1. Then we check. Right is but interval is smaller, so we don't increment, and this one becomes 3. I plus plus. That's cool. The next is I equal to 2, so it's 1, 3. 1 is larger, no. 1 is larger than 3, no. Now 3 is larger than no, so... Huh? Oh, RM. RM. Oh, hold a second. Hold a second. This is where we got wrong. -1, 1, and then now -1, 3. Right? Huh. Hold on. So the 0 is not, okay. And then this is also larger than. Then we say if original is this and this is larger than, then we have to increment. Otherwise we don't increment. Oh, okay. So I think here is where we got wrong. We need to make some changes. If this, okay, and hold a second. So if this new extension to the right, right, new extension to the right, then we say if if we don't have a, no, hold on. If the start is smaller than 0, okay? If the start is smaller than 0, then we never touch the next RM. We can always increment the current. Hold on. If the next because we sort based on the starting point, so the smaller than 0 always gets first, right? So if it's smaller than 0, right, so I think this should be like this. If right, and we say if intervals I0 is smaller or equal to 0, right? If it's smaller or equal to 0, then we don't do anything. We just say rm shall equal to max rm and intervals. Oh, it's already larger than, so it's pretty obvious. Shall equal to intervals I1, right? It's larger than. Right extend more, so we always do this. Now we have an else. Else. If, which means the left is larger than 0, right? It's larger than 0, so we have to use the second consideration. Then we have to check. If the next does not exist, then we have to create a new next, increment the result. Okay, if we handle it this way, does this give me the right result? It gave me 3, right? This one gave me 3. Okay, let's try. this one in. Need to add a new tab. So this is no need to add new tab because the current one always covers 0. Okay, let's run this, see if it's correct. Run again. All right, how many have we passed? 30 out of 38. We're getting close. Getting close. Okay, so what's this one? 8 4 0 0 0. Oof. Rough. 0 0 0 4 0 0 0 4 4 0 0 0 4 3 0 4 3 0 4. Okay. All right, let's see. Debug this thing. We have intervals. Oof. Rough. Okay, what do we have? Intervals. We have -4 4 0 8 1 1 2 2 3 3 4 12 5 5 6 6 and 7 7. And the goal, right, is to cover from 0 to 8. Okay, well, cover from 0 to 8. So first one we get a 4. Right. Next one we'll get to 8. Wait, isn't that done? Should that be 1? Yeah. That should be 1. Oh, I continued. Oh. I should not continue. While this and, not and, next, and RM is smaller than N, and next RM is smaller than N. Any one of them is smaller than N. Okay, if we run this, that becomes 1. So let me add this condition to the top. Yeah, that was an oversight. The first time we can cover, we just exit. Try this. This one we got it. We got an August badge as well. Well, we did sort on log n. The rest shall be on because each one gets run at most twice. But we got pretty bad runtime though. Sort by the left interval. Then we use greedy. For each for each interval, we want to find the max right. Right, I want to find a max right before the left goes beyond the previous max right. Right, so we want to find a max right before the left goes beyond the previous right. Thus, we set up two values, rm and next rm. For each where rm is the current max right and next rm is the next max right. Actually, I should say the max right before the left goes beyond the current. For each interval, if the left right is larger than rm, we have gone beyond the current max right. In this case, if we have a if we also goes beyond the next max right, we have a gap, we have a unfillable gap, return -1. Otherwise, we forget, we replace, otherwise our next rm becomes the current rm, and we reanalyze the current interval. If the left is smaller or equal to rm, and if the right is also smaller or equal to rm, we do nothing, because the current interval does not contribute anything. If the right is smaller, no. If the right is bigger than rm, okay? The right is bigger than rm. There are multiple conditions. 1. Left is smaller than 0. This means the current interval covers 0, and we simply maximize rm without touching next rm or incrementing res. Left, otherwise, if our right is otherwise if next rm does not exist, this means the current interval's right is the first extension, right? First extension to the right, and we shall count this as a new tab. if next rm already exists, then the tab has been opened, has been counted, right? The final step is to maximize next rm. Okay, so O and log n plus n. Pretty mediocre performance. And it's kind of late, so I don't want to read the solutions. Dynamic programming. I did not think about DP. I was using greedy. Oh, we can avoid sorting. Okay. I like to run these just for fun. I think my DP and my greedy is slightly different. Min jumps to reach end of array. Anyway, we're gonna have to look this tomorrow because I kind of don't want to keep going.